Hello guys, welcome to Ask Raghulan. Today we're going to see what is happening with Chandrayaan. So why it is on news at the moment, and what is the status of the mission, and what was the actual mission is, and what they're trying to accomplish. Because every mission, most of these space missions, they have multiple parts into it. So which portion of it is actually in trouble, which portion is actually completed, which is in successful state. So that is all the stuff that we're going to see today. So now before we get through it, as usual, we'll get through some basics, some history about this incidents and what happened before and right now. So that's what we're going to do now. So very first thing, what Chandrayaan is trying to do is put a lander rover onto the moon surface. So that is what they're trying to achieve. So now for that to happen, they need to send a payload, which the rover and everything, a lander and everything, to the moon, and then they have to safely land it, and then the rover does the job. So this was something the Chinese mission has done it a few months ago. So that's the same thing that we planned a few years ago. That is what we're doing now. Okay, so now let's get through the history now. So before we get through it, some of the little things here. So this is a moon and this is your Earth, and the distance between them is around 3.8 lakh kilometers. So that's a pretty far distance, pretty far from the Earth. So it may not look as when you look at your moon from here. So it's actually 3.8 kilometers from the surface of your Earth. And then the mission takes 2 months of travel time. So that means when the rocket leaves the Earth's surface, it generally takes around 2 months to reach close to the moon's orbiter. So that is basically the duration for it to reach it. And then the mission time is around 14 days. So the 14 days is the time where they maneuver it, put the orbiter in place, and then release the payload on which actually the lander. It's like a mini rocket which actually has some propulsion system which actually reduces the sort of force when it actually lands it up. We'll go through the details as we go through those ones. And then once it lands up, then it releases a rover. So it pretty much opens the doors and the rover droids open it. And this is the same thing what people have done it in Mars, and NASA has done it in Mars and other things. So that is what they're trying to achieve here. So now little other information here. So there is a lot of other factors that needs to be considered. One is there is your Earth gravitational pull, and then there is moon's gravitational pull. The funny thing with the moon's gravitational pull is the moon has got a lot of little lumps here and there, because there is a lot of craters that has been created with lots of meteors that hit the moon for over millions of years. So now the lumps actually makes the gravitational force irregular. So it's very hard to calculate when you're actually maneuvering the orbiter to place the orbiter into the moon's orbit to put into a stable orbit which is around 100 kilometers from the moon. So it is very difficult to adjust it, because people here on Earth has a communication delay, because the signal has to travel over 3.8 kilometers, and then the data that comes from there, and the people they do the maneuvers, so they have to do calculations in between as well. So it's a very, very tricky mission. Even the orbiter is a tricky mission. So if you look at it in the history, Russia, China, India, and USA have all launched landers as well as orbiter missions. Orbiter missions are tentatively bit more successful compared to the lander missions, and the lander missions are very tricky because there is lots of factors that has to go in there. So we will see the failure rates of other nations as well, so then you can understand the gravity of the situation. So now, once they maneuver pretty much the package, and then it's in the orbiter, and then it takes care of the rest of the work. So now before this one, then the main portion of this one is there are actually three things that goes in there. So one is the Chandrayaan, which is the orbiter, which actually goes around the moon, and then taking photographs and 3D topology data and all that kind of stuff. And then the second one is Vikram lander. So that is actually like a little vehicle which actually lands on the surface of the moon, and which carries actually the rover. The vehicle itself doesn't have any purpose other than having some power storage and things like that. But the rover is the one, actually the inspection vehicle, which actually goes onto the surface of the moon, rides into different location, and grabs some data, and then samples and things like that. And then Pragyan rover. So this is actually the name of the rover. So there's actually three portions of this mission. So the first portion, orbiter, which is 100% done, which is working, that is fine. So another thing which the little news about the orbiter is, orbiter generally comes with amount of fuel for it to actually adjust the orbital rotations which actually goes around the moon. So sometimes what happens is, since the moon has got a gravitational pull, since this little satellite which is actually orbiting around the moon, sometimes it gets closer and closer and closer, and then finally it crashes onto the moon. So this is exactly what happens with our international space stations, and every other satellite goes around. So in order to avoid it to crash it onto the surface, generally people have a propulsion system which actually pushes the orbiter away from the moon, or if it is going away from the moon, generally what happens is, if it goes too away from the moon, generally it leaves the orbiter and goes into the empty space. So we don't want both these scenarios to happen. So it actually has to sit between a range where the moon's gravitational pull is actually keeping it around it. The same way how a moon has been rotating the earth for centuries, that's the same thing what these people want to do with these little satellites. So now the difficult part of this one is, they have limited supply of fuel that they can carry, because this doesn't work with electric power. They need actually the liquid or solid propellant to actually use it when it actually adjusts the orbitals to move for closer and away from the actual orbital range from the moon. So now this one is actually a limited supply of fuel. So the satellite has got lifetime within which once the fuel got away, then the satellite generally crashes away. This is the same thing with every other satellite. So now the good thing about this one is, they sent it with 1.5 years of fuel, and now since part of the mission has gone haywire, so they're saying that they have enough fuel for 7 years. So that means this orbital will be serving us for 7 years, taking lots and lots of data from the southern part of it or around the moon. So that's the status of that one here. And let's take a look at the history from here to here. So in 2008 October, Chandrayaan 1 was launched. This is actually the first mission before they launched Chandrayaan 2. This is actually Chandrayaan 2 which is in trouble right now, but they launched the Chandrayaan 1 in 2008 October. So the payload consists of 11 payloads, and 1 from India, and 3 from Europe, and 2 from USA, and 1 from Bulgaria, and rest of the payloads actually has like a subunits for the Indian payloads. So next is your discovery of water. What they are trying to achieve with the Chandrayaan 1 is discovery of water in moon. So that's what the main mission is. And the second one is take 3 topo information of the chemical composition of the moon surface. So now why this is two things are very important is, so what people around the world trying to work with moon is, basically they wanted to have moon as a sub base for humans to settle down and have a stable colony, so we can do further space exploration having moon as a base. The problem with Earth is, we are having a thick atmosphere and we have very high gravitational force. So every time we want to get away from that, we need to spend lots and lots of fuel, resources, and then energy and everything, and also it risk, because we are actually getting away from the atmosphere, and which is very thick, and so it creates a lot of friction. That's what caused a lot of previous accidents as well. So with moon, it's vacuum, so we don't have to worry about surface frictions and all this kind of stuff. So people trying to establish a stable colony in moon, so from there we can explore rest of the planetaries in the solar system or beyond the solar system in coming future. So now this is not just for the governments to work on it. There are plenty and plenty of private companies who are actually getting into launching private little satellites into space. So some of the companies which have done it successfully are SpaceX, which is the Elon Musk company, which is SpaceX. They have launched several satellites successfully, and they also have a reusable module, fuselage module, so which they can keep using it for multiple missions. And the same way, there is a lot of other companies which does that. Plenty of them. So one of them is Space IO. So that's actually European version of sort of like a SpaceX version, but a smaller version. And they launch smaller private satellites in space. Most of these are, like say, TV companies or mobile phone companies for communications, GPS companies, navigation, a lot of these companies. So they wanted to put some satellites in there to do for their work. So now, so with the second mission, which is Chandrayaan 2, so this was launched in 22nd July 2019 at 1:43 p.m. You know, it's a Sanskrit name for moon. Chandrayaan is actually a Sanskrit name for moon, and they launched it in a specific time. They planned it and they launched it at the exact time. And then the liftoff, and the vehicle they used is GSLV Mark II. That was a launch vehicle they used. That's actually the rocket which actually carries the satellite. So that is the rocket, and then they took 13 payloads. I think most of it actually are Indian payloads, 13 payloads. And then the very first image, that means, once the satellite goes closer to the moon, and then, because what happens is the satellite goes here, and before even it actually starts setting into the orbital, it can actually take photos because it's all separate functions. So now on 4th of August 2019, it sends its very first image of the moon surface. So that pretty much the Chandrayaan is actually going closer to the moon and starts sending photos. And then on 14th of August 2019, it actually get into the lunar transfer trajectory. So trajectory is basically when you throw something, when it goes up, it creates a curve and then it comes down. So that is called a trajectory. So when it actually, the satellite goes into the orbital of the moon, it cannot just go straight and join the orbital. It has to go in a sort of like curve. So that is the trajectory they use it to make sure that it doesn't actually use it sort of like a slingshot. Basically, it goes along with the orbital and then joins the correct orbital so that it can circle around the moon. So now that was on 14th of August. Then on 20th of August, it was in the lunar orbit. So it successfully joined the lunar orbit, and then now it's actually doing the orbitals around the moon every day. So now another thing is that you need to know is, like, say, 1 day in moon is equivalent to 14 days on Earth. And that's because moon always faces the Earth. So that means whenever the Earth rotates 14 times, pretty much the moon sort of comes around, has its own rotation as well. So that is the 1 day of moon equal to 14 days in 14 Earth days. So next, on 2nd of September, so they separated the Vikram lander from the main orbital. So that is when it actually separated from the Chandrayaan, and then the Vikram is actually the landing vehicle which will be landed onto the moon, from which the rover will ride open and come out of it. So that was on 2nd of September. It went really well. Only on 7th of September, that is the last Saturday, so when they were trying to do a soft landing, so what happens is there is actually a types of braking, different types of braking. So one is a harsh braking, another one is fine braking. So what happens is when the lander approaches the surface, they will do a very harsh braking to reduce the velocity at which it actually going to land onto the surface. And moment it actually goes closer to a certain distance, it actually uses fine braking. So the fine braking is basically, it uses the propulsion to do minor adjustments to make sure that the lander doesn't hit hard onto the surface, so that it doesn't damage anything that it actually carries. So that is actually two things. So now the issue with that one is there is a lot more stuff that goes in there rather than we just think it outside of the box. So now first thing is there is a local moon gravity. The moon gravity is different from the Earth's gravity. So the moon gravity, as I said, every location has got different gravity, and it's just because there is a lot of lumps and a lot of craters and things like that. So the gravity is actually a little different in the poles as well. So there is a lot more calculation that needs to be done. So people have done meticulously. It's like, it's way too hard even to predict it from here on Earth. So it's one of the toughest thing. And then there is lunar dust. That is not going to be a bigger issue compared to the rest of the items. What happens is lunar dust, you can imagine it's like fine particles of glass. So that is how the lunar, you can say it as like sort of like a sand. It's a sort of like a silica material. It's a very fine jagged edges. It is called jagged edges as well. So what it is like, if you just look at closer, it looks like sharp edged knives, and it's pretty much, it's like glass, and it's very fine. So now the problem with that is when it actually the rover lands onto the moon, the dust, because since it's vacuum, the dust actually goes above and then settles on top of the lander everywhere, including the solar panels. So the reason it actually stays, it's not just stays on it, it actually sticks to it. The reason being is that dust, since it has got a jagged edges, when it actually moves, when it frictions with one another, it gets a negative energy, negative charges, and then it sticks to the lander. And since the lander is opposite charge, so it actually sticks to the lander. So it's too hard to get rid of it. So if it sticks on top of the solar panel, generally it actually blocks the solar light, and then the lander doesn't receive any energy, and then it goes down. So that is one of the risks. Another one is the autonomous control. The problem with that is, since it's actually going towards the southern pole of the moon, the lander has to do the adjustment on its own. So that means there is no human intervention when it actually does the landing. So moment it actually goes and starts landing, so the communication from the base station is not actually reaching the lander to adjust any more corrections. So what it does is, based on the distance, based on how velocity and all this stuff, they have programmed it to do, the propulsion system has to fire it in parallelly as well, along with the rover engine, whatever it asks you to do. So it's like multiple systems have to coordinate with each other, and then it has to land it automatically by itself. So there is no human error up here. So it's basically the lander has to land it. And then finally there is communication shadows. Even if everything goes well, even if the lander lands in successfully, sometimes what happens is the lander goes inside a crater. Now you're looking at it, the craters are 70 to 80 kilometers wide. You can imagine it's a city block, entire city block. That's how big the craters are. Sometimes the craters are too deep, so that way the orbital which is actually going around the moon will not be able to communicate with the lander which lands onto the craters. So the reason people choose craters to land is, the moon surface, as I said, sometimes it might be very soft as well. So the landers cannot land on very soft surface. If it's a crater, generally it might have a lot consolidated, so it's more settled, it's compared to more soft areas. So now this is all the stuff. Now if you compare with other 4 countries which have done similar things, USA, Russia, Israel and China, and China and Israel, they have got few missions in their pockets, and they're all recent missions. And USA has got around from 1958 to 1965 they got around 13 failures, and Russia has got 17 failures. And then with in 66 to 76, there were around 2 failures, and for Russia, they got around 9 failures. So they have success, but if you look at the early stages, they got quite a bit more failures, and compared to the success rate should be around 2 or 3 or something like that. So if you can imagine, we have gone to the moon, and first portion of the mission is done. So the Chandrayaan is still going to send us photos for the next 7 years and so on. So that portion of it is done. Only the second portion and third portion, which is already proved to be very difficult. Already these nations which have done several missions, they have even got a manned mission to moon with using the Apollo 11, have failed it several times. So you can understand, so it's a sort of very difficult mission to accomplish. So now the point is, right now they have got it landed, so it looks like it's a very harsh land, and the communication equipment might have been broken. So they're trying to enable communications between the lander and the orbital, and hopefully it comes back. And then maybe a power surge, maybe any sensor issues, could be any of those things. So once it fires up, if you're able to get some transmissions, and then we would be good to go. But if not, still almost the main mission, half of the mission is successful. So that's all the updates for today, guys. And hope you like the videos, and if you have any comments, please put it on to the comment section. And if you like the video, subscribe to the channel. Thank you.